Welcome to The Deep Dive, the show where we take a stack of your most interesting sources and unpack them into most important nuggets of knowledge and insight. Our mission? Well, it's to give you a shortcut to being truly well-informed, complete with surprising facts, and, just enough humor to keep you hooked. Today, we're embarking on a deep dive into the, fascinating world of AI-powered products. We're drawing heavily from comprehensive excerpts of Building AI-Powered Products by Dr. Nika. And this isn't just about the latest AI buzzwords you hear everywhere, It's about peeling back the layers to understand the very essence of how artificial intelligence is being transformed, from complex, often abstract research into practical, impactful solutions. Solutions that, frankly, many of us interact with every single day. Our goal for this deep dive is, kind of threefold. First, to explore the current and evolving landscape of AI, give you a clear picture of where we are and maybe where we're headed. Second, we'll zero in on the unique, pivotal role of product managers in bringing these innovations to life.
And third, we'll unpack the critical strategies and challenges involved in building truly valuable, user-centric AI-powered experiences. So, get ready for some serious aha moments, because we're about to uncover how groundbreaking technologies are actively shaping our digital future.
Yeah, and what's truly fascinating about this moment is just how rapidly the world of AI is shifting. Moving from purely theoretical concepts to becoming really integral parts of our daily routines. This deep dive will offer more than just a list of what AI can do. It'll help us understand why it matters so profoundly for innovation and, maybe more importantly, how truly impactful products are actually built around it.
Okay, let's unpack this then. When we look at where AI is today, it's pretty clear we've witnessed an incredible acceleration. I mean, AI has been a core research area for decades, right?
Oh, yeah.
But there's just no denying that recent breakthroughs, I'm thinking especially around 2023 with models like OpenAI's ChatGPT, they truly transformed the landscape. It really felt like overnight AI went from academic papers to, mainstream conversation.
It really did. It was quite a moment. And what we've seen since then is what Dr. Nika aptly calls a Cambrian explosion of generative AI models. And we're not just talking about a handful of new tools popping up. No, it's this vast and really rapid proliferation of capabilities. We're talking incredibly sophisticated image generators like Midjourney, Stable Diffusion, DALL-E, the ones that can conjure stunning visuals from just simple text prompts.
Right. Those are everywhere now.
Exactly. And we've seen advanced search solutions like DeepSeek trying to provide more refined, contextually aware results, moving beyond just keywords. And the advancements even extend to multimodal systems like Google's Gemini, which can process and understand information across different modalities, text, images, audio, video, all at the same time. Yeah, this rapid expansion is so profound that, most tech companies are now prioritizing integrating some aspect of AI into their core strategies. The shift is unmistakable. Organizations are moving towards developing more general-purpose AI, things that can handle a wider array of tasks, and even building highly personalized AI agents. Agents that cater specifically to individual user needs and preferences. It's a fundamental reorientation of the entire tech industry, really, and it's happening at warp speed.
That explosion sounds, truly transformative. But right from the preface, Dr. Nika highlights this crucial philosophy. AI is not the product. The experience is the product. For someone trying to get their head around this space, what's the biggest mistake companies make when they, forget this philosophy?
That's an excellent question. It really gets right to the heart of successful AI product development.
Yeah.
I'd say the biggest mistake companies make when they forget that AI is not the product, the experience is the product, is falling into the shiny object trap,
Chasing the tech?
Precisely. They become so enamored with the technology itself, the complex algorithms, the impressive model capabilities, that they end up building products around the AI rather than for the user. So they might launch a chatbot just because they have a powerful language model, but without deeply considering if that chatbot truly solves an unmet user need, or if it integrates seamlessly into a workflow.
Right. So you get tech for tech's sake.
Exactly. And the result, products that are technically impressive, maybe, but functionally clunky, confusing, or just irrelevant to users' actual lives.
Yeah.
To deliver genuine value, AI can't just stand alone as a piece of tech, no matter how cool it is. It has to be seamlessly integrated into an existing experience, or maybe it needs to be the engine creating an entirely new, enhanced experience. The technology is just a means to an end. It's really about how that AI contributes to a user's journey, how it solves a need or makes a task more efficient or enjoyable or valuable. And this philosophy, it has to guide the entire product development process, from the very first spark of an idea right through to the final rollout. making sure innovation always serves a real-world purpose for the user. It's absolutely critical for anyone looking to bring these AI experiences to life, especially if you're collaborating with technical teams.
So it's really about what the tech does for people, not just the tech itself.
Okay, it's fascinating then how our source categorizes modern-day AI into these 4 stages of evolution. It really helps put things into perspective. Given this incredible trajectory, if you had to pick one stage that represents the biggest societal shift, which one would it be and why?
That's a thoughtful question. Because honestly, each stage brings pretty profound changes. Generative AI is causing the most immediate stir right now, obviously. But I'd argue that artificial general intelligence, AGI, even though it's still largely a projection maybe sometime in the 2030s,
Yeah,
that represents the biggest potential societal shift.
AGI. Why AGI specifically? Well, because traditional AI and even generative AI, as impactful as they are, primarily automate or augment specific tasks.
Right.
They're tools. They enhance human capabilities or create new content within defined boundaries. AGI, though, aims for machines that can understand, learn, and apply knowledge across a wide range of tasks, essentially mimicking human cognitive functions in a general way. This isn't just about solving a problem, but about generalized problem solving, tackling novel situations. If AGI truly materializes, and that's still a big if, it would mean a fundamental redefinition of work, creativity, maybe even human potential itself.
Wow. That's huge.
Imagine an AI that can not only diagnose a rare disease, but also conceptualize a new treatment pathway or manage complex global supply chains while, simultaneously engaging in philosophical debate. The breadth of its potential impact moves beyond specific industries and really into the very fabric of human society.
Okay, so maybe walk us through those 4 stages again, just to make sure we're all on the same page.
Sure, absolutely. So first, we have traditional AI. This really spans from the 1950s right up to the present day. These are the foundational technologies. They were designed for specific tasks using rule-based systems or, later, more sophisticated pattern recognition. Think computer vision that powers image and face recognition, letting you tag friends in photos or enabling security systems.
Okay, like photo tagging. Got it.
Exactly. It also includes speech recognition, fundamental to voice assistants like Siri or Alexa, and basic natural language processing, or NLP, which helps computers understand human language for things like keyword searches. These are already deeply embedded everywhere.
Right.
Next is generative AI, or Gen AI. This emerged in the late 2010s and is obviously very much present now. This is the recent wave that's really captivated public attention. It's defining abilities to create content, text, images, video, music, code, often from simple prompts.
The creation aspect is key.
It is, and it's crucial to understand that Gen AI doesn't replace traditional AI. It just opens up entirely new dimensions. Examples are tools like DALL-E, Midjourney, Adobe Firefly. They're revolutionizing creative arts and business. Gen AI is also behind personalized media platforms like Netflix and Spotify, tailoring suggestions. It's even getting into game development, creating more interactive worlds. And of course, there are the ethical concerns around things like deepfakes.
Yeah, that's a big one.
Then looking to the future, we have artificial general intelligence, AGI, maybe around the 2030s. As I mentioned, this is the next big frontier. The goal is machines that can understand, learn, and apply knowledge across a wide range of tasks, mimicking human cognitive functions. True general problem solving. Dr. Nika points to potential breakthroughs here in general problem solving, approaching novel challenges with human-like reasoning, and in healthcare. Think highly personalized medicine, diagnosing complex conditions, maybe even proposing new treatments.
The potential seems almost limitless there.
It does. And finally, the most ambitious and currently hypothetical stage is artificial superintelligence, ASI, maybe the 2040s or beyond. This concept envisions AI surpassing human intelligence in virtually every domain.
Okay, now that really sounds like science fiction.
It does feel that way. But if ASI becomes reality, it could offer revolutionary solutions to humanity's biggest challenges, climate change, world hunger, maybe even geopolitical conflicts, by offering insights we can't currently grasp. It could provide reliable foresight, making future forecasts incredibly accurate. And it could accelerate things like advanced space exploration, solving incredibly complex problems.
Wow. This evolution is truly mind-bending. From specific tasks to potentially solving global challenges, it really puts the ambition of AI into sharp focus. So given this rapidly expanding AI landscape, it quickly becomes clear that a critical role emerges, the AI Product Manager, or AIPM. What makes this role so unique? And maybe what's the single hardest part of communicating its complexities to, say, non-technical stakeholders?
That's a great question because it is a unique and really demanding role. The AI PM is essentially the vital bridge, the translator, if you will. They connect these complex AI technologies with real-world user problems. Their core job is translating highly technical advancements, deep machine learning models, complex algorithms into user-driven solutions that actually provide tangible value.
So they need to speak both languages, tech, and user needs.
Exactly. Dr. Nika shares a fascinating personal story from the early days of voice assistants. She talks about designing smart home assistants that needed to understand all sorts of accents, even recognize who was speaking. She realized she was right at the heart of AI product management, wrangling massive data sets, refining algorithms, figuring out how to embed this cutting-edge tech into products people could actually use. It demands this unique blend. Technical understanding, knowing what AI can and can't do, combined with deep user empathy, identifying genuine needs that AI can actually address.
Okay, so the hardest part of explaining that to non-technical folks?
Right. I think it's the probabilistic nature of AI. That's the real hurdle. When you explain that an AI system might predict an image contains a dog with, say, 80% certainty, but there's still a 20% chance it's something else, maybe even a cat. That's tough for someone used to deterministic software.
Because regular software just works or it doesn't, right? It follows the rules.
Precisely. Traditional software is binary. AI operates in shades of gray. Explaining that an AI-powered self-driving car, no matter how advanced, will always have some tiny non-zero chance of error, or that a medical diagnostic AI gives probabilities, not certainties. That goes against intuition for many.
Yeah, I can see that being a challenge, especially for high-stakes stuff.
Exactly. AI PMs have to manage this inherent uncertainty, setting clear expectations with stakeholders, with users about the likelihood of errors, and understanding the intricate trade-offs, accuracy versus speed or cost. This is especially critical in high-stakes areas like self-driving cars, where tiny errors can have huge consequences, or healthcare diagnostics, where a misdiagnosis is obviously very serious.
Okay, so the probabilistic nature is a big one. What other unique challenges does the AI PM face?
Well, beyond that fundamental aspect, there are several others that really differentiate it from traditional product management. One is model drift. Unlike traditional software that stays static unless you manually update it, AI models are dynamic. They learn, they evolve as they see new data and get user feedback.
So they're not one-and-done releases.
Not at all. AI PMs need to plan for long-term maintenance. That means regular retraining schedules, robust feedback mechanisms. Think about Google Maps asking you to confirm location accuracy. That feedback goes right back into the model. It's a continuous improvement cycle.
Okay, model drift. What else?
Then there's model interpretability and explainability, often called XAI. Many complex AI models, especially deep neural networks, are kind of like black boxes.
Meaning we don't really know how they reach a decision?
Exactly. The answer might be right, but the why is hidden. This is a huge challenge, especially in sectors like finance, legal, healthcare, where transparency and accountability are absolutely critical. So the AIPM has to balance model performance with interpretability. Sometimes the most accurate models are the least explainable.
Tricky.
Very. In those cases, PMs might use specialized tools like Esche or Lime to try and explain why a decision was made, like why a loan was denied. And the user interface itself needs to provide clear explanations to build trust.
Makes sense. Keep going.
Okay, next is automated decision making. AI's ability to make decisions autonomously, chatbots handling queries, systems optimizing supply chains, autonomous vehicles navigating offers huge efficiency gains. But this also fundamentally shifts responsibility. The AI PM has to decide where to draw the line. When does the AI get full control? And when is human oversight essential?
The human-in-the-loop idea.
Precisely. Often leading to human-in-the-loop approaches where AI recommends, but a human makes the final call, especially in high-stakes situations. You need fail-safes, escalation paths. And finally, scalability. AI's strength is scaling, making thousands of decisions per second. But this demands robust infrastructure, performance optimization, serious data handling. AI models are resource hungry. PMs need to plan for this from day one, choosing the right cloud platforms, designing data architectures that can handle growth without costs exploding. Optimization is key.
That's a lot to consider. It definitely sounds like the AI PM needs to wear many, many hats. But what excites me is how these unique characteristics translate into tangible benefits. Dr. Nika details 7 superpowers that AI and GenAI offer. When you look at this list, which one do you think is least understood by the average user, even though it has a profound impact?
That's an insightful way to frame it. Users definitely experience the results of all these superpowers, but I think the one that's probably least understood in its true depth is learning from massive data and content.
Really? Why that one?
Because people know their Spotify makes good recommendations, right, or
Hmm.
Netflix, but they don't always grasp the sheer scale and complexity of the data processing happening behind the curtain. The analysis of billions of user interactions, content attributes, real-time signals, all that allows the AI to derive those precise insights and make predictions. It's sort of the silent engine fueling so much of what they perceive as magic. They see the result, not the immense machinery behind it.
Okay, that makes sense. So walk us through all 7 superpowers.
Happy to. Number one, as we just discussed, is learning from massive data and content. AI systems analyze vast amounts of user-generated content, past interactions, clicks, searches, viewing history to derive deep insights and make accurate predictions. Spotify recommendations, Google Maps, traffic predictions. It's all AI processing enormous data sets. Gene AI pushes this further, synthesizing data for ultra-personalized suggestions that are adapt in real time.
Got it. Number 2.
Personalization at scale. AI delivers tailored experiences to millions simultaneously, dynamically adapting to evolving preferences. Pinterest crafting design suggestions based on your changing tastes is a good example. It understands patterns in large groups, then fine-tunes for individuals, highly relevant, continually adaptive experiences at massive scale.
Impressive. 3.
Automating and optimizing workflows. AI offloads tedious manual work scheduling, emails. Gen AI elevates this by not just automating, but optimizing based on real-time data. Imagine an AI assistant scheduling meetings and analyzing team availability to optimize overall productivity. Smarter, more efficient tools.
Okay, 4 must be content generation.
You got it. Generating new content and experiences. This is Gen AI's core strength, its most revolutionary impact, especially creatively. ChatGPT writing reports, DALL-E generating visuals, Adobe's generative design tool creating graphics. It revolutionizes how content is produced and consumed. Prediction and forecasting. AI has been doing this for decades, predicting trends, inventory, market behavior. Gen AI enhances this. It processes complex data sets more deeply for more accurate predictions and, crucially, generates actionable insights. Like a stock forecasting tool predicting behavior and suggesting strategies. More intelligent decision-making.
6 sounds like real-time interaction.
Exactly, real-time adaptation. AI enables instant interactions, Siri, Alexa, chatbots. Gen AI's ability to adapt on the fly is key here. It understands nuanced inputs, delivers refined outputs in real time, allowing for dynamic conversational interactions that improve as the conversation progresses.
And the last one, number 7.
Unlocking new types of user experiences with new form factors. AI isn't just on screens. It's deeply integrated into smart glasses, VR headsets, wearables like the Aura Ring or Meta's Ray-Ban AI glasses. These blend the physical and digital, creating immersive, seamless experiences, entirely new ways to interact with AI.
These superpowers really aren't just theoretical, are they? They translate directly into benefits we see, or maybe sometimes don't consciously see, but experience. It hammers home that point. AI isn't the goal, it's the tool for creating these incredible experiences. So with all this potential, how do these amazing AI products actually get built? Dr. Nika introduces a 5-stage framework, the AI Product Development Lifecycle, or AIPDL. Sounds like a roadmap.
It is exactly that. The AIPDL is a comprehensive and, importantly, iterative process. It guides AI-powered products from identifying a business problem right through to delivering a market-ready solution. And the key focus throughout is ensuring product-market fit. It consists of 5 key stages. 1, ideation, mapping AI capabilities to a user pain point. 2, opportunity, assessing the idea's market fit, potential viability, feasibility, desirability. 3, concept prototype, scoping the work, training the models, integrating them into an experience. This is often where the core AI lifecycle sits within the broader product lifecycle. 4, testing and analysis, gathering rigorous feedback, validating hypotheses, ensuring minimum viable quality. And 5, rollout, productionizing the solution, making it accessible, followed by continuous monitoring and iteration.
And iterative is key, right? You might loop back.
Absolutely, especially in AI development. Things change, you learn, models drift, so cycling back through stages as you refine is very common, very necessary.
Okay, let's dive into ideation first. That's where it all begins. Dr. Nika mentions adopting an innovation-first mindset, citing Steve Jobs. People don't know what they want until you show it to them. How does an AI PM actually foster that kind of creative thinking? And what's a common trap they should definitely avoid here?
Fostering that creativity really boils down to constantly envisioning unique, novel ways AI can serve specific users and solve their problems. For 0 to 1 products, brand new things built from scratch, it's about identifying truly untapped markets, unmet needs. This usually means intensive brainstorming, market research, forming bold hypotheses, and often close collaboration with AI researchers to push the technical boundaries.
Okay, that's for new products. What about enhancing existing ones?
Right. For 110 products, enhancing what's already there, the focus shifts. It's more about improving the existing experience. This means working very closely with UX teams, digging into existing user data to pinpoint where AI can add value or efficiency. But regardless of the type, ideas must be user-centric. Dr. Nika gives a great example with Starbucks. AI could predict busy times at local stores, suggest optimal pickup times, or use recommendations to prioritize your usual order. Maybe suggest new drinks based on your taste profile. It's about optimizing for reach and impact by focusing on high-value customer needs.
And the common trap to avoid during ideation.
The big one is the shiny AI object trap we mentioned earlier. Resisting that urge to launch something just because the underlying AI tech is cool. You absolutely have to do your homework. Ensure the product roadmap aligns with clear business objectives and a genuine user need. Don't build AI just because you can. Build it because it solves a real problem.
Okay, solid advice. What about other do's and don'ts?
Yeah, Dr. Nika lays out some clear ones. A big do is, do solve the right problem. Validate that users are genuinely bothered by something before you build an AI solution for it. The Dyson example is perfect. They saw people hated cords, validated it, then built the cordless vacuum, solved a real pain point. Also, do understand feature impact. If you add an AI feature to an existing product, make sure it improves things or at least doesn't mess up what's already working. And a crucial don't. Don't talk about a hunch without data. A good PM needs analytical skills. Proposals should be backed by data market research, user feedback, analysis of similar past efforts, and their ROI. Data-backed ideas get buy-in, period.
That clarity makes a lot of sense. So you brainstorm, you follow the do's and don'ts, you end up with a long list of ideas.
Yeah.
How do you prioritize? That's where the RICE framework comes in, right?
That's right. RICE stands for Reach, Impact, Confidence, and Effort. It's a really powerful prioritization tool. Helps PMs make more objective, data-driven decisions about which features to actually pursue.
Break down those components for us.
Sure. Reach estimates how many users a feature will affect in a given time. Impact gauges how much that feature will move key metrics or solve a user's problem, often on a subjective scale, like 1 to 5. Confidence reflects your certainty in your reach and impact estimates. It acknowledges the uncertainty, which is especially important with AI's probabilistic nature. You might express this as a percentage. And effort estimates the total work involved for the entire team, product, design, engineering, data science, usually in person months.
Okay. Reach, impact, confidence, effort. How do you put it together?
The RICE score is calculated simply as reach X, impact X, confidence, effort. Higher scores get higher priority. So imagine Netflix. They might use RICE to compare features like avoiding repeated recommendations versus peer recommendations versus an enhanced watch list. Each gets scored based on estimated reach, potential impact, confidence in those estimates, and the effort needed. Dr. Nika also suggests an optional but very relevant addition for AI, an AI investment parameter. This would account for unique AI costs, data collection, compute power for training, ongoing maintenance. So the formula becomes RAIACEAA, where A is AI investment. Gives a more specific view for AI products.
That refinement makes a lot of sense for AI. Okay, so
Yeah.
RICE helps prioritize. That takes us directly to the opportunity phase. This is where you really assess the market potential, right? What's the biggest gotcha here for AI products specifically?
Yes, exactly. The opportunity phase is all about rigorously testing your hypothesis for product market fit. You start with a clear hypothesis like, binge watchers will return more often if our recommendations are accurate. Then you dive deep. Analyze competitors, alternatives, market size, timing. Now, the biggest gotcha for AI products here, it often lies at the intersection of business viability and user desirability, especially when the technical feasibility seems high.
Meaning you could build it, people might want it, but
But it fundamentally clashes with privacy regulations, ethical expectations, or maybe the business model just doesn't work long term. It won't be viable in the marketplace, even if it's technically cool and users initially seem interested.
Okay. Let's break down those 3 criteria then.
Right, the 3 crucial criteria for product market fit. First, business viability. Can the product actually generate sustainable revenue in a competitive market? This involves market research, competitor analysis, calculating ROI, net return cost of investment. It also means careful risk evaluation, technological, market, financial, timing risks. And crucially for AI, business viability heavily involves regulatory compliance, GDPR, the EU AI Act, IKA, and building customer trust through ethical AI practices, often using explainable AI, XAI tools like Ashe and Lime so people understand why a decision was made.
Okay, viability, number 2.
Technical feasibility. Does your organization actually have the resources, the tech experts, hardware, software, data, compute power to build it? And maybe most critically for AI, data availability and quality. Data is the lifeblood. Is it there? Is it clean? This step sets realistic expectations.
And the third, user desirability.
User desirability. Will users actually want this solution? And importantly, will they pay for it? You assess this through surveys, interviews, competitive pricing analysis, prototyping with an MVP to gauge real interest and willingness to pay. Dr. Nika includes a useful product market fit scale figure that shows signals from actual money and product market fit are much stronger indicators than just attention or time spent with a free product.
Got it. And all 3 need to be met.
Absolutely. All 3 pillars, viability, feasibility, desirability, must be solid. If anyone is weak or missing, the product is highly unlikely to succeed long-term.
I love the example Dr. Nika gives about a mood-based music suggestion algorithm. It sounds desirable, maybe technically feasible, but the source says it might have low business viability. This really highlights your point about that. Gotcha.
It really does. Perfect illustration. Such an AI product.
Yeah.
Yeah, it sounds interesting, technically doable perhaps, but it would face huge privacy and social monitoring concerns.
Right. Collecting emotional data. Yikes.
Exactly. Gathering sensitive emotional data, maybe from audio or biosignals, it raises massive ethical and legal flags. So, despite the technical coolness and maybe even user interest, the immense business risks and regulatory hurdles would make it incredibly difficult to achieve market sustainability. It just highlights that a product has to meet all 3 criteria. Technical prowess and user interest aren't enough if the business or ethical environment is impossible.
Okay. So after ideation and opportunity assessment, we move to concept prototype, building an MVP, a minimum viable product. How is an AI MVP different from a traditional software MVP? What's the key difference in mindset needed here?
That's a crucial distinction. A traditional MVP often focuses on just the simplest version to validate a core hypothesis. But an AI MVP has specific requirements reflecting AI's unique nature, the key mindset difference. An AI MVP isn't just about functionality. It's also about validating the learnability and adaptability of the AI right from day one, often using human feedback loops. It's about showing the potential to get smarter.
Okay, so what does an AI MVP need to do specifically?
Dr. Nika outlines 4 key things. 1, it must require putting together a hard-coded experience. Focus on the AI's core value prop without fully automating everything initially. You hard-code some parts to demo the main benefit, letting stakeholders see the potential while you build the complex AI bits in parallel. Avoids wasting time on non-core automation early on.
Makes sense. Keep it focused.
2, it needs to demonstrate ideally low-effort integration compatibility. AI products need to fit into existing systems, often via APIs. The MVP should show it can integrate, proving technical feasibility and showing how it enhances, not disrupts, current workflows. Even simple sample integrations help.
Right. Show it plays nice with others.
3, it needs to showcase domain-specific expertise. The AI has to prove it understands the specific area it's operating in. If it's a sales prediction tool, the MVP should show it can pull and analyze relevant CRM data and export insights.
Prove it knows its stuff.
And 4, crucially, it must add value from day one. Even if it's imperfect and designed to improve, the AI MVP has to deliver tangible, immediate benefits. Maybe a more personalized experience, some efficiency gain, actionable insights. Building in a feedback loop for user corrections, like tracking clicks on recommendations, is a great way to show how it learns and improves. Validates the concept, hints at future effectiveness.
Okay, got it. Value from day one, potential to learn. And then once you have that MVP, it's all about testing and analysis and rollout.
Correct. The testing and analysis phase is that critical bridge between prototype and market launch. It involves rigorous evaluation, structured feedback sessions with users, maybe beta releases or phased rollouts. You gather feedback using surveys, interviews, focus groups, maybe advanced analytics scanning user interactions for satisfaction or friction points.
And this leads to the big decision.
Exactly. The culmination is the critical go-no-go decision. Stakeholders assess all the data, technical readiness, user satisfaction, market conditions to decide if the product is truly ready. Go means launch. No-go means back to refinement.
Okay. And if it's go, then roll out.
Then rollout. This signifies the transition to making the product available to the target market. It demands meticulous planning, marketing strategy, target segments, messaging, channels, logistics, generating buzz with previews, early access, and post-deployment, the focus shifts immediately to continuous monitoring and maintenance, regularly evaluating model accuracy and performance, feeding new data for adaptation, staying vigilant about bias and ethics. Rollout is iterative too. Teams continuously monitor market trends, regulatory changes, implement updates. Got to stay competitive and valuable in this fast-moving landscape.
Wow. This deep dive is truly delivering on making dense topics interesting. Okay, Dr. Nika then shifts gears to the essential skills an AIPM needs. She groups them into 4 buckets. It sounds like the AIPM needs a crystal ball and maybe a therapist.
Laughs. Sometimes it might feel that way. But these buckets are really crucial for anyone aspiring to be, or currently working as, an AI PM. They provide a comprehensive map of the necessary capabilities. They are 1. Core product management craft and practices, foundational PM skills, but viewed through an AI lens. 2. Engineering foundations for PMs, understanding how software, especially AI infrastructure, is built. 3. Essential leadership and collaboration skills, the people skills, aligning diverse teams, driving innovation. And 4, AI lifecycle and operational awareness, deep knowledge of AI-specific development stages and how to manage them. Dr. Nika emphasizes that many core PM skills remain essential, but they get significantly amplified and recontextualized when you add AI to the mix.
Let's talk about those core PM skills first. Identifying user segments, writing user stories, these are fundamental. But what makes writing user stories even more critical when you're building with AI?
That's a fantastic point. User stories become even more critical and maybe more nuanced in AIPM because they act as that vital bridge. They translate complex, sometimes opaque technical possibilities into accessible, tangible user benefits. They ensure development stays firmly user-centric, anchoring advanced machine functionality to actual human needs.
Why more critical, though?
Because with AI, the how can be so complex, so black boxy sometimes. The user story forces clarity on the desired outcome from the user's perspective without getting lost in the weeds of the model's inner workings. It holds the team accountable to delivering user value, not just clever tech.
Okay, so it keeps the focus on the user outcome.
Exactly. Dr. Nika provides a clear template, who the user is, what their use case is, and what their expectation or desired outcome is. Simple but powerful.
Can you give us some examples?
Sure. Let's take Netflix recommendations again. A user story might be: as a Netflix viewer who often ignores specific show recommendations, I want the system to notice I'm not interested, so that my recommendations become more relevant to my actual tastes. See? It directly addresses a user frustration with the current AI.
Okay, yeah, that's clear. Another one.
How about a dating app like Tinder or Bumble? As a user who values shared hobbies and interests, I want the matching algorithm to prioritize profiles based on mutual hobbies and maybe core beliefs, so that I can find matches with whom I have more in common, leading to potentially more meaningful connections. Here, the AI is explicitly tasked with deepening connections based on specific user values.
Got it. One more, maybe for something like Tesla.
Sure, for self-driving. As a Tesla owner interested in autonomous driving, I want the self-driving system to recognize and adjust adaptively to different weather and road conditions, so that I can ensure a safer and more reliable autonomous driving experience in various environments. This focuses on the AI's adaptability for safety and reliability.
Those examples really bring it to life. Okay, but a big part of any PM role is assessing trade-offs. What are the unique, perhaps unexpected trade-offs an AI PM faces that differ significantly from traditional product management?
This is where it gets really interesting, because AI introduces new, often complex layers of trade-offs that AI PMs are constantly navigating. It's not like traditional software where rules are fixed. AI's probabilistic learning nature means decisions aren't always straightforward. It's a constant tightrope walk.
Okay, give us some examples of these unique AI trade-offs.
Right. First, there's accuracy versus speed. Think autonomous vehicles. Object recognition needs to be highly accurate and millisecond fast for split-second decisions. Too much accuracy focus might delay response. Too much speed might cause errors. PMs have to define that acceptable balance.
Okay, accuracy versus speed. What else?
Complexity versus simplicity. AI models range from super complex deep learning networks to simpler rule-based systems. A complex NLP model for a chatbot might sound more human-like, but it's harder to debug, harder to maintain. Simply models are transparent but might not perform as well. The PM decides if the extra complexity is worth the user benefit.
Makes sense.
Then, data quality versus quantity. AI systems are data hungry, we know that, but there's a big trade-off between just grabbing huge amounts of data and ensuring it's high quality, relevant, and ethically sourced, especially in fields like healthcare. You need lots of patient data, but it must be accurate, labeled correctly, compliant with privacy rules. Bad data undermines everything.
Quality over just quantity, potentially.
Yes. Next, generalization versus specificity. Do you build one general-purpose model for, say, recommendations across movies, books, and music, or do you build specialized models for each? General models have broader reach but might lose accuracy compared to specialized ones. PM's way broader utility against performance.
Okay. Privacy must be one too.
Absolutely. User privacy versus personalization. Tailored experiences often rely on analyzing user data. This directly clashes with privacy concerns, especially with GDPR and other regulations. Balancing this might mean sacrificing some personalization features to maintain trust, or investing in privacy-preserving AI techniques.
Ethical consideration.
Big one. Ethical considerations versus business goals. AI systems bring up huge ethical concerns. Bias, fairness, transparency. An AI hiring tool must be bias-free, but business pressure might push for speed or cost cuts. PMs have to champion fairness and ethics, even if it slows things down or impacts short-term efficiency.
And explainability.
Right, explainability versus performance. Highly accurate black box models like deep neural networks are often unexplainable, but in critical areas like credit scoring or medical diagnostics, people need to understand the why. PMs must balance top performance with the need for models that can explain themselves, sometimes accepting a slight performance hit for transparency and trust.
So what does this all mean for decision-making? It sounds like you're constantly navigating this really complex space where every choice has ripple effects.
Exactly. It's constant navigation. Dr. Nika describes this as defining your trade space. It's not about picking A or B. It's like imagining all these factors, cost, time, expertise, risk, ethics, tech constraints, as sliders.
Sliders, like on a mixing board.
Kind of. You position each slider precisely within this multidimensional space. The acceptable solution, the sweet spot for your product, lies where the limits of all these sliders intersect. That forms your solution space. This dynamic visualization helps AI PMs make more informed strategic decisions, and it's often used when presenting to leadership. Show the pros and cons clearly. For example, the source has a table comparing on-device versus cloud processing, weighing user experience, ethics, compliance, resources, tech constraints for each.
Okay, the slider analogy helps visualize it.
It allows you to explicitly call out the risks and opportunities with each trade-off. Ensures choices are well understood across the board.
Dr. Nika also provides a deeper look at the AI lifecycle, emphasizing a human-in-the-loop approach. We hear this phrase a lot, but why is human involvement so crucial throughout an AI product's journey? What happens if you try to take the human out too early?
That's a fantastic question, and it's where many companies stumble, honestly.
Yeah.
The human-in-the-loop concept. It's vital because AI functions best not in isolation, but when working alongside human expertise and oversight. It's fundamentally about augmenting human capabilities, not entirely replacing them.
So what happens if you do try to take the human out too early?
You risk building an AI that's efficient on paper, maybe, but ultimately flawed, biased, or just doesn't truly understand the nuance of human needs and real-world complexities. You end up with a product that fails to gain user trust, or maybe it's just not useful in practice. It misses the mark.
Okay, so how is the human involved throughout the life cycle?
It's interwoven. Starts right at project scoping. PMs create product requirements, documents, PRDs defining objectives, user needs, success metrics. Engineers translate these into technical boundaries. Human vision sets the stage. Then data collection. Human input is absolutely crucial here. Data labeling often requires human expertise, especially for complex stuff like medical images or financial analysis. Human annotators ensure data accuracy, relevance, context, reducing bias.
Labeling is key.
Huge. Then during model training, PMs need an experimental mindset. Human oversight helps minimize loss functions like mean squared error, MSE. Think of the loss function as the AI's report card, measuring how wrong it is. Minimizing it means better accuracy. Engineers iterate and human understanding guides refinements.
Okay. Training and then testing.
Right. In validation and testing, human evaluation is essential. It spots subtle errors or biases that automated metrics might miss. Really crucial in high-stakes environments. The AI PM, guided by user expectations and risk tolerance, sets the minimum viable quality, MVQ. For a medical tool, maybe that's 95% accuracy.
And even after deployment.
Absolutely. Finally, in deployment, when the model goes live, the human element doesn't vanish. Continuous monitoring involves human oversight. But more importantly, you need human feedback loops. Products should let users give real-time feedback on recommendations or decisions. That feedback cycles back into data collection and retraining. It's an ongoing improvement process. This constant human feedback makes the AI adaptable, ethical, and aligned with evolving user needs.
That iterative loop, with humans constantly refining the AI, is truly fascinating. Dr. Nika also maps out various AI algorithms and their applications, which helps clarify the different approaches. For our listeners who are already following the topic, what's truly fascinating is how a PM grapples with the unique data challenges for each of these learning methods in the real world.
You've hit on a core challenge for AI PMs there. Many people understand what these methods are conceptually, but managing their unique data demands, that's where the rubber meets the road. The map you mentioned, Figure 3.5, is a great visual guide. It breaks down learning methods, algorithms, applications, use cases, shows how different tech converges.
So let's talk about those data challenges. Start with supervised learning.
Okay, supervised learning trains on labeled data. Each piece of data has the right answer attached, most common type. The unique data challenge for a PM here, the immense cost and effort of getting high-quality, accurately labeled data at scale. Human annotation for complex scenarios is a major bottleneck.
Right. Costly and time-consuming labeling.
Exactly. It's used for classification, sentiment analysis, dating app matching, image classification, medical diagnostics, and regression predicting future values, like sales forecasting or optimizing logistics. Think fraud detection learning from past labeled transactions.
Okay. Next, self-supervised learning.
Self-supervised learning. This learns from unlabeled data by generating its own labels, like predicting missing words in text, crucial for large language models, LLMs, and transformers. The data challenge here shifts. You have tons of unlabeled data, sure, but ensuring its diversity and representativeness is key. You need to prevent the model learning biases present in vast, uncurated internet data.
So avoiding bias in the unlabeled source data.
Precisely. Applications include speech processing, multimodal learning, advanced NLP, powers sophisticated chatbots, and content synthesis.
Unsupervised learning.
Unsupervised learning finds hidden patterns in unlabeled data without guidance. The data challenge for PMs. Validating the meaningfulness of the patterns the AI finds. Since there are no right answers, PMs need domain experts to confirm if the clusters or reductions are actually useful for the business.
Making sure the patterns aren't just noise.
Exactly. It excels at clustering anomaly detection and fraud, image segmentation, customer segmentation, and dimensionality reduction compressing data, visualizing complex data.
And finally, reinforcement learning.
Reinforcement learning. RL. An agent learns by interacting with an environment, getting rewards or penalties, often boosted by neural networks. The data challenge for RL. Setting up the right environment and reward function. You need to ensure the AI learns the desired behavior without unintended negative consequences. Generating enough realistic training interactions, sometimes through simulations, can be immensely complex and time-consuming.
Defining the rewards correctly seems tricky.
It really is. RL is strong for prediction and evaluation, like in personalized medicine, and control and optimization financial trading, multi-armed bandit algorithms for recommendations, autonomous vehicles, robotics.
This brings us to a really important point Dr. Nika mentions. Responsible AI practices. What does that specifically entail for an AI PM, and what's the most common blind spot companies have when trying to implement them?
Responsible AI practices. It means embedding ethical considerations, fairness, accountability, transparency, ethics, often called FATE, into every single stage. For an AI PM, it's not an add-on. It has to be a proactive mindset from the start, asking critical questions like, who will this impact? What potential harms could arise?
And the most common blind spot.
Assuming good intentions are enough. Companies often think, we mean well, so our AI will be fair. They overlook the subtle biases that can creep into data or algorithms without anyone realizing it.
Like the hiring tool example.
Exactly. An AI hiring tool might unintentionally favor certain demographics if trained on skewed data, leading to discrimination. Predictive policing algorithms might target minority communities if trained on historically biased data. Good intentions don't prevent bad outcomes if you're not careful.
So what are the key practices to mitigate this?
Several crucial ones. First, diverse data sets. Models are only as good as their training data. Ensuring datasets represent diverse demographics, geographies, contexts is essential to minimize bias, like a face recognition system needing images of all skin tones. Second, stress testing. PMs need to test the product with a wide array of edge cases to find and fix vulnerabilities before deployment. Third, compliance. Adhering to regulations like GDPR, the EU AI Act, AIPDL. This means audits ensuring legal requirements for data handling, consent, transparency are met. And fourth, explainable AI. XAI. This is key. Designing systems to be understandable and not black boxes. Builds trust, aids debugging bias, ensures compliance. Using tools like Heshup or Lime to explain decisions, like why a loan was denied. Ultimately, it's about positioning AI products as trustworthy, mitigating risks, and building a foundation for sustainable humanitarian use of AI.
It certainly sounds like a lot of strategic thinking goes into this role. Okay, Dr. Nika directly addresses a critical question many companies face. Should we build our AI solutions in-house or buy them from a third party? What's the hidden long-term cost if you make the wrong decision here?
Yeah, that's a core strategic dilemma, and the decision has huge implications. Resources, time to market, long-term control. It affects everything. The hidden long-term cost of getting it wrong. Often it comes down to either loss of differentiation if you buy something generic when you need it custom, or lost opportunity and wasted resources if you try to build something complex in-house when a perfectly good solution already exists.
Okay, so break down the pros of building in-house.
Building in-house offers big advantages. First, customization. You can tailor the AI precisely to your unique needs, ensuring it evolves with your business, ideal for highly specialized tasks. Second, full ownership. You keep complete control over the tech, your data, the model itself. Hugely valuable if proprietary data or differentiation is your competitive edge.
Data security too, I imagine.
Absolutely. Data security. Keeping data in-house reduces breach risks, gives stricter control over compliance like GDPR, and potentially long-term cost savings. Initial investment is higher talent, infrastructure, time. But avoiding ongoing vendor fees can save a lot down the road.
Okay, those are strong arguments for building. What about buying?
Buying a pre-trained solution also has compelling advantages. Primarily, faster time to market. Integrating a ready-made model is much quicker. Critical in fast-moving markets, especially for maybe secondary AI features. And access to expertise. You get immediate access to specialized knowledge, models already tested by the vendor across industries. Higher reliability from day one.
So how do you decide?
Dr. Nika provides a helpful decision matrix. It weighs factors like, is AI a core competency for you? What resources do you have? How urgent is time to market? What are the costs initial and ongoing? What are the risks? Data privacy concerns. Often, the best strategy ends up being a hybrid approach.
Meaning do both.
Yeah. Build your core differentiating AI components in-house, the stuff that makes you unique. But leverage third-party solutions for non-essential or supplementary capabilities, like build your secret sauce recommendation engine, but use a standard language model via API for basic NLP tasks. Get the best of both worlds.
Okay, hybrid makes sense. Now, Dr. Nika also brings up Clayton Christensen's innovator's dilemma, that classic concept of disruptive versus sustaining innovation, and how it applies to AI. How does AI amplify the complexities of that dilemma?
It's a fantastic point, and AI absolutely amplifies its complexities. Christensen's dilemma, just to recap, explores how successful companies, doing everything right for their existing customers, can still fail when faced with disruptive tech.
Right, because they focus on current needs, not future ones.
Exactly. You have two types of innovation. Sustaining innovations. These improve existing products for current customers, usually incremental better performance, fewer defects, like adding AI predictive analytics to an existing product for better personalization, serves established markets.
Okay, that's sustaining. What about disruptive?
Disruptive innovations are different. They introduce something new, often targeting niche markets or unmet needs initially. They might even seem inferior on traditional metrics at first, but they offer different advantages: lower cost, convenience, new functions.
Like the smartphone camera example. Initially, worse image quality, but way more convenient.
Perfect example. They prioritize different things, target new segments. Over time, they improve, often redefine the market, and displace established players.
So how does AI amplify this?
Because AI-powered disruptive innovations can scale and improve exponentially through learning. Their inferior early stage can very quickly blossom into market dominance. For AI PMs, this means a critical strategic choice. Focus on enhancing current products with AI sustaining. Or challenge the status quo, create entirely new AI-driven categories targeting unmet needs, disruptive. The disruptive path carries higher risk, obviously, but also much higher potential reward. It forces companies to question what even their existing customers might value in the future, not just today.
That's a tough strategic tightrope. Okay, so once you've decided on build versus buy and maybe sustaining versus disruptive, then comes the data. Dr. Nika talks about populating and adapting your model, including using synthetic data. What's the difference, and when would you use each, especially when privacy is a big concern?
Right. Data is the fuel. Deciding between real-world and synthetic data, or blending them, is a key strategic choice. Real-world data is just that gathered from actual user interactions, historical records, sensors, authentic sources. It's ideal when user behavior and preferences are central, as real data captures true nuances, or when you need cultural or contextual subtleties, or for high-stakes decisions needing real-world accuracy.
Okay, real-world data is the baseline. What about synthetic?
Synthetic data is artificially generated, created algorithmically to mimic the statistical properties of real data. It's not collected from actual events. It's particularly useful when you're dealing with sensitive information, healthcare, finance. Using real patient or financial data raises huge privacy or regulatory issues. Synthetic data lets you develop and test without compromising privacy. That's a big one.
Okay, so privacy protection is a major use case.
Definitely. Also, when you need to test rare but critical scenarios, like specific accident types for self-driving cars, these don't happen often in real life, but the model must handle them. Synthetic data lets you create those scenarios. And in early development, when you need to move fast or real data collection is just too expensive or slow, synthetic data can provide the volume needed to get models started.
So companies like Tesla use both.
Exactly. Dr. Nika points out they blend synthetic scenarios with real-world driving data. The key is knowing when to use which. And generating good synthetic data is tricky. It needs the right statistical properties without adding new biases. You always want to validate it against real samples if possible.
And then there are different ways to train or adapt these models. Fine-tuning, RAG, grounding. For a PM, what's the primary strategic consideration when choosing among these three?
The primary strategic consideration really boils down to balancing three things: resource allocation, time, compute power, data needed, the desired specificity or accuracy, and the need for the information to be up to date. Each method offers a different trade-off here.
Okay, let's break them down. Fine-tuning first.
Fine-tuning. You take a big pre-trained model that already knows general stuff and train it further on a smaller, specific labeled dataset for your particular task. It's resource-intensive needs, labeled data, lots of compute, but gives high accuracy and specialization. Strategic consideration. Choose fine-tuning when deep specialization and high accuracy for a specific task are paramount, and you have the labeled data and compute resources. Great for core differentiating AI features.
Okay. What about RAG? Retrieval Augmented Generation.
RAG. This enhances generative models by letting them access an external, up-to-date knowledge base dynamically without retraining the whole base model. User asks a question, RAG retrieves relevant info first, then uses that info to generate the answer. Strategic consideration. RAG is best for information-heavy contexts where data changes frequently or needs to be current. It's less resource-intensive than fine-tuning for keeping things updated. Excellent for needing real-time relevance, like recommending music based on current trends.
And grounding.
Grounding. This is a more lightweight approach. Uses pre-existing context, often delivered via prompt engineering, to guide a base model's behavior. You give instructions or context to influence responses without changing the model's core or retrieving external data dynamically. Strategic consideration. Grounding is ideal for rapid iterations, or when the model only needs slight adjustments. Less resource-intensive, quicker to implement. Great at early experiments or influencing a chatbot's tone without deep model changes.
That really clarifies how models are refined. But how do you know if all this effort is actually working? Dr. Nika emphasizes that unpacking success in AI products can be surprisingly challenging because no single metric captures it all. So for a PM focused on, say, a fraud detection system, why might precision be more critical than recall, even if it means sacrificing some recall?
That's an excellent question. Gets right to the heart of nuanced metric selection. You're right. The real insights come from what Dr. Nika calls an AI product metric blend, a balanced mix of diverse metrics. Relying on just one is almost always misleading. Now, for fraud detection, prioritizing precision over recall highlights the business impact of false positives.
Okay, remind us what precision and recall are in this context.
Sure. Precision asks, of all the transactions the model flagged as fraud, how many were actually fraud? High precision means fewer legitimate transactions get wrongly flagged. Recall, or sensitivity, asks, Of all the actual fraud cases that happen, how many did the model correctly catch? High recall means missing less actual fraud.
Okay, so why favor precision?
Because in fraud detection, a high number of false positives flagging good transactions as fraud can be incredibly damaging to the user experience. Imagine your card getting declined when you're trying to buy something important because the AI mistakenly thought it was fraud.
Yeah, that's super frustrating.
Exactly. Leads to user anger, abandoned purchases, maybe even customers switching providers. So while you don't want to miss actual fraud, low recall, the cost of annoying or losing good customers due to too many false alarms can be far greater. A PM might strategically prioritize precision to maintain customer satisfaction and trust, even if it means accepting a slightly higher risk of missing some fraud, lower recall. It's a business trade-off.
Okay, that makes the trade-off clear. So this metric blend has categories.
Right. Dr. Nika breaks it into 3 key categories. 1, product health metrics. These measure user interaction, engagement, satisfaction. Things like engagement, how often, how long users interact, user satisfaction, NPS, surveys, adoption, new user rate, conversion, achieving goals like closing sales, retention and churn, keeping users versus losing them, and basic financial metrics, revenue, ROI.
Okay, product health. What's next?
2, system health metrics, technical performance, often behind the scenes but crucial for user experience, like uptime and latency, system availability response speed, scalability, handling load, error rate, frequency of system errors.
And the third category is specific to the AI itself.
Exactly. 3, AI proxy metrics. These assess the underlying AI model's performance, which indirectly impacts the other 2. Examples include model quality metrics like accuracy, precision, recall, sensitivity, ROC curves, the ones we just discussed for fraud, objective functions like mean squared error, MSE, that the model tries to minimize during training, and confusion matrices, which are tables comparing actual versus predicted outcomes, true positive, true negative, false positive, false negative, to see exactly where the model is succeeding or failing, like in spam classification.
This multifaceted approach to measuring success is essential, especially when we talk about OKRs, objectives, and key results for AI products. How does this blend fit into OKRs?
A well-rounded OKR framework for AI products absolutely should integrate this blend. You need a North Star metric, the primary measure of success, but it should be supported by key performance indicators, KPIs, from all 3 buckets: product health, system health, and AI proxy metrics. Ensures a holistic view. Dr. Nika provides a fantastic example for a music streaming services recommendation system. Objective: enhance user experience via more personalized music recommendations. The user-focused goal. Specific features. Introduce 3 new personalization algorithms. The actions. North Star metric, KPI. Increase user engagement with recommended playlists by 25%. Primary success indicator.
Okay, that's the main goal. Then the supporting metrics.
Right. Product health metric. Reduce song skips within AI playlists by 20%. Measures user satisfaction with recommendations. Guardrail metric. Ensure overall listening time doesn't decrease by more than 5%. Crucial do no harm metric. System health metric. Maintain 99% uptime. Reduce playlist loading times to under 1 second. Technical reliability. And AI proxy metric. Increase the recommendation algorithm's precision by 15%. Underlying model quality.
That's a really clear way to set actionable, balanced goals. It's definitely about more than just the AI working. It's about the AI delivering real value to the user in the business. Okay, our discussion takes us even further into the future of AI with a deep dive into AI agents. Now, this sounds like a huge leap beyond just chatbots. Frankly, a little like science fiction coming to life. What exactly is an AI agent, and what's the fundamental difference that sets them apart from something like, say, ChatGPT?
You're right, it does feel a bit sci-fi, and AI agents are fundamentally transforming industries, automating tasks, enhancing experiences far beyond what traditional chatbots could manage. Drawing from researchers Poole and Mackworth, an intelligent agent basically acts in an environment, and it acts intelligently if its actions are appropriate for its goals and circumstances, if it's flexible to change, learns from experience, and makes good choices despite limitations. Adaptability and learning are key. These systems have evolved into autonomous entities. They don't just understand user needs. They can anticipate them, execute complex tasks, refine their behavior through interaction.
Okay, so the key difference from ChatGPT.
It really comes down to autonomy and goal orientation. ChatGPT, while incredibly impressive as a large language model, is primarily a conversational model. It responds to prompts based on its training data. It generates coherent text, but it lacks true autonomy.
Doesn't act on its own.
Exactly. It doesn't independently perform tasks or make decisions on your behalf without constant, explicit input. It doesn't have a goal-driven framework to proactively act within an environment in an agentic way. AI agents, on the other hand, are designed to be autonomous and goal-driven. They can perform specific tasks, make decisions, take actions on their own initiative. Now, Dr. Nika points out that custom versions, like OpenAI's custom GTTs or Google's Gemini Gems, can be considered agents when they're tailored to execute tasks autonomously, often by combining instructions with external knowledge or skills.
So when they're set up to do things.
Right. When they operate with less need for constant user prompts, acting more proactively towards a user's goal, they can interact with other tools, automate workflows via things like Zapier. They become purposeful experiences, like NotebookLM acting as a dedicated research assistant.
So definitely not just glorified chatbots. That's what many might assume.
Not at all. It's a common misconception. While both use NLP, the scope, complexity, capabilities of agents are far beyond traditional chatbots. Chatbots typically are rule-based. They handle specific inputs with scripted dialogues, think basic customer service bots answering, "Where's my order?" Their conversation flow is predefined, autonomy is minimal. They're sophisticated scripts, basically.
Okay. And agents are different how? What are their defining components?
AI agents are designed to learn, adapt, act autonomously. Dr. Nika outlines several key components. Abilities, the tasks they can perform, speech recognition, decision-making, etc. Goals, preferences, what they aim to achieve, maximize satisfaction, optimize workflow. Environment, the context they operate in and sense stimuli from. Actions, how they interact with that environment, learning from experience. They refine behavior over time. Recommendation systems get better, making decisions, evaluating options, choosing responses based on data and goals, and taking autonomous action. This is the big leap. Proactive decisions based on user intent, scheduling meetings, generating content without direct intervention.
Dr. Nika provides a fantastic comparison table contrasting chatbots, AI agents, and even multi-agents. It really shows the progression.
Yeah, that table clearly illustrates the evolution in complexity and autonomy. Chatbots. Single, narrow scope, rule-based decisions, minimal autonomy, low complexity, predefined conversation flow, use cases, FAQs, basic reservations, basically automated scripts.
Okay. Then agents.
AI agents. Single but broad scope. Adaptive learning, decision-making. Adaptive autonomy makes choices within parameters. Medium-high complexity. Adapt to changing info environments. Use cases. Personal assistance, advanced customer support.
And multi-agents. That sounds complex.
Multi-agents. Very complex. Multiple agents working together. Complex distributed scope. Collaborative emergent decision-making. Collective actions optimize outcomes. High coordinated autonomy. Very high complexity. Adapt individually and collectively in real time. Envisioned uses. Autonomous driving with coordinated cars communicating, or virtual hospitals with multiple AI agents collaborating on patient care. It shows a clear path forward.
That really makes the distinction sharp. So for a product manager, how do you go about crafting the right AI agent for a product? What's the biggest design challenge you might face when considering these different activation and autonomy levels?
Well, you always start with the user's most urgent need, a well-defined use case. Focus where AI can have the most immediate, impactful effect, automating customer service, streamlining processes, enhancing experiences. The biggest design challenge when considering activation and autonomy is probably managing user trust and control. It's a really delicate balance.
How so?
How proactive should the agent be without feeling creepy or intrusive? How much autonomy can it have before the user feels like they've lost control or don't understand what it's doing? Nailing that balance is tough.
Okay. So what are the key considerations when designing an agent?
Several key things to decide. First, task-specific vertical agents versus general-purpose agents. Vertical agents are specialized. Email filtering, customer support, note summarization like NotebookLM can be simple reflex agents, goal-based, optimizing sales, or utility-based, minimizing energy use. Yeah. Great for repetitive tasks. General-purpose agents handle wide varieties of tasks across domains, adapting, like Siri or Alexa.
Okay, specific versus general purpose. What else?
Second, agent activation. Will it be proactive or reactive? Proactive agents initiate interactions based on context or behavior, like dynamic yield offering recommendations as you browse, or Zapier automating workflows. Reactive agents respond only when explicitly invoked, like BotPress or HubSpot's chatbot builder. Depends on the scenario.
Proactive versus reactive. Then autonomy levels.
Third, defining autonomy levels. How independent is the agent? This is crucial. Assistance. Lowest level provides info, recommendations like Gemini suggesting products. Guided tasks, guides the user, fills details, but user keeps control, like a kayak agent helping book a flight with user input. Full automation, highest level. Executes tasks end-to-end, like hyperrate booking flights autonomously. You need to carefully decide the right level for the context.
And learning.
Finally, feedback and learning. Does the agent need to learn over time? Requires reinforcement learning capabilities, feedback loops explicit, user ratings, or implicit analyzing interactions for continuous improvement.
Okay. How do these agents actually look and feel when you're interacting with them? Dr. Nika shares several design patterns, which is helpful to visualize.
Yeah, the UI and interaction patterns are absolutely crucial for how an agent is perceived and used. Dr. Nika shares several common ones. One is the side panel. Persistent, accessible UI for contextual help, great for productivity tools. Think Microsoft Copilot in Office apps or Hyperwrite for writing tasks. Always there, but not disruptive.
Okay. Side panel. What else?
The floating bubble. More compact widget, sits on the edge, expands on click. Less intrusive, like Drift's interface for quick support. Discrete until needed.
Integrated UI?
Integrated UI, seamlessly built into the workflow, offers suggestions without a dedicated interface. Ideal for proactive agents subtly enhancing things, Grammarly is perfect, real-time corrections as you type, or Tesla's autopilot, fundamentally integrated.
Pop-up.
Pop-up notifications, best for proactive agents giving timely advice. Grammarly uses these two, suggesting improvements right when needed.
And a collaborative browser one sounds interesting.
Right, the collaborative browser interface. Unique design, seen in OpenAI's operator. Blends autonomous action with manual control. User can take control mid-task, like making a restaurant reservation, adjust details, then hand back control for the agent to resume. Great for combining automation and human oversight, like comparing ticket prices or filling complex forms.
That's an incredible range of possibilities for interaction. Finally, what does success look like for an AI agent? Is it different from other AI products?
It shares similarities, but success still requires that blended approach. Looking at performance, user satisfaction, business impact, no single metric works. Key metrics include task completion rate, fundamental, did it actually do what it was supposed to do, accuracy, how precise were its responses or actions, latency, response time, slow agents are frustrating, user retention, do people keep using it, shows ongoing value, cost efficiency, savings or revenue generated versus cost, did it reduce workload or increase sales, intervention, how often does a human need to step in? Success means this decreases over time, and of course, satisfaction. Direct user feedback. Was it useful? Easy to interact with. Tracking this blend gives AI PMs a holistic view, ensuring the agent delivers value to users and the business.
What a deep dive. Seriously. We've unpacked the incredible evolution of AI from those traditional systems right through to this fascinating realm of AI agents. We've explored the unique challenges those superpowers AI PMs leverage to turn complex tech into valuable user experiences. From the stages of the AIPDL, the build versus buy decisions, measuring success, it's clear building these products is both an art and a science.
Yeah, and connecting it to the bigger picture, it really hammers home that AI isn't static. It's this continuously evolving force. It demands constant learning, adaptability from product leaders, concepts like probabilistic nature, model drift, explainable AI. They're critical for building trust, ensuring ethical deployment. It's a dynamic field where navigating uncertainty is just as vital as technical skill.
This deep dive really makes you think, doesn't it? About how every interaction we have with technology is being reshaped, often in ways we don't even notice. For you, the listener, whether you're prepping for a meeting, trying to catch up on this field, or maybe you're just insanely curious, we really hope this has given you a robust foundation, understanding the why and the how behind this AI revolution. And here's a provocative thought to leave you with. As AI agents become more autonomous, blurring those lines between just helping out and full automation, what ethical responsibilities fall to us, to the users? How do we shape their learning and ensure they continue to serve humanity's best interests? Something to mull over. Thank you so much for joining us on the deep dive. If this sparked your curiosity, remember there's always more to explore. We'll be back soon with another fascinating topic.